So 5.7 in the Redwood's pre-algebra textbook talks about square roots. This is a concept that is in almost every textbook out there that deals with topics of pre-algebra and algebra. But it's important to know how what square roots are, how they work, and so on. So in our book, Tools for Mastering Mathematics, which I'll just call TFMM right now, we have a part 1, 2, and 3. In part 2, we actually give you a table of numbers, the squared version, and then the cubed version. So 1 squared, which is 1, 1 cubed, which is 1, 2, and then 2 squared, which is 4, 2 cubed, which is 8, and so on and so forth. We give you this for values up to 20. I see in your book you're giving these values for the squares up to 25. So the number x squared is called the square of the number x, right? So x squared is x times x, right? So if I give you a value like 25, it can be written as 5 times 5. So the square root of 25 is actually 5, right? And this is something that you learn in, as I said, in pre-algebra especially. So they discuss briefly some examples of square roots in the first section here on page 425. They go over examples and then they explain square root. If a squared is equal to b, then a is called the square root of the number b. So if a squared is equal to b, as they said, then a is called the square root of the number b. So the square root of the number b would be what a would be, right? Because a is equal to the square root of b. In order to find a, you would have to take the square root of both sides. This is just more of the technical terminology. But the general idea, again, is if you're asked to find the square roots of a number, like 9, it would be plus 3 and minus 3. So you could say plus 3 and minus 3. That would be how you would find the square roots of 9. So let's see. So you find the square roots of the number you have. In this one, they say 256. Find the square roots of the number 256. So you would have negative 16 and 16. So that is how we find the square roots of 256, for example. To find the square root of, let's use 81, it will be plus 9 and negative 9. So that's how we do that one as well. And so that's the beginning of this section, dealing with square roots. Just be comfortable with, your roots all the way to, I would say all the way to 15 is a good one. Just knowing it all the way to 15, that's not a bad idea. So finding the square roots, the tables are given to you there. If you're asked to find the square root of 0, it's just 0. We've looked at a few examples. When you're given a negative number and you're asked to find the square root of a negative number, like negative 9, at this point in your math career, the answer to that is actually none. There's a reason why I say that, because later on you'll learn about something called complex numbers. But at this point, you just say none. So if you have a square root of a negative number, the answer is just none. So then on page 427, it goes into talking about radical notation. If you have a square root of 9, for example, in what you're seeing right now, we have a radicand. We know the radical is that symbol there. The radicand is the thing that is inside. It's the content of what's in that. So that is something to keep in mind for this section as well. So then it goes on to example 5. It gives you more problems that you're working with. Now keep in mind that if you have negative and then I put this 36, the answer to this problem would be negative 6. You're allowed to evaluate the square root of 36 and then you apply that negative at the end. That is fine. You just can't have an answer if I ask for the square root of negative 36 at this point. We haven't covered complex numbers yet. So that's those are some important pieces to keep in mind. Moving on to the next page on 428, you have more examples explaining this. Again, like the example with 36 that I gave you, that is explained on that page. Order of operations, I would say that whenever possible, you should try and you make sure you simplify the radicand, if it can, or the radical. So let's look at this example. It'll explain some of the point. But if you have a situation like this, you would want to simplify this first. So notice what I just did. I took the square root of 4 and I changed it to 2. I took the square root of 9 and I changed that to 3. And now we have 4 minus 9, which is negative 5. So that's how we simplify that problem. You always want to simplify the radical if you can, and then you go from there. Now, radicals behave in a similar way to like terms. So if you have 2 radical 2 plus 2 radical 2, the answer is 4 radical 2. So it's kind of like 2x plus 2x will be 4x, right? That's how that one works. So that's how the radical works in this case. So then we have example 8. We're looking at the you try this section where it says 5 minus, we have 8 and then square root of 169. So we can simplify this. This is 169 is a perfect square. So we know that becomes a 13 there. So basically you have 5 times 8 times negative 13. Now remember with PEMDAS, you have to do the multiplication first. So what's 8 times 12, right? And then you add 8 again to it. So we have 8 times 12, we have 96, plus 8 again, we have 104. And so 5 minus 104 is equal to negative 99. So that's how we get the answer to that problem. When you are asked to simplify a problem like this, 25 plus 144. When you're asked to solve a problem like that, you can add 144 plus 25, and that's 169. So that becomes the square root of 169, which is 13. Notice that you have to add these two first before you apply the radical. If you have a situation where it's what is the square root of 25 plus the square root of 144, you deal with them individually. And the answer is 17. Notice that the answer to this problem, the one on the left, is not equal to the one on the right. Why is that important? Because you can't split a radical into 2 radicals like this situation. You can't do that. You have to treat what's in here first, right? You have to treat what's here, 25 plus 144. And that's how you get to your answer. And in this case, there were 2 separate radicals, which is no problem. You just have to evaluate them individually. So that's how that principle works. So when you have a fraction or decimal, you can also be asked to find or simplify and get the value with the radical. So let's say we have these 2 situations. For this first situation, you can split it into 2. That is legal in math. You are allowed to split it into 2. So what do I mean by splitting it into 2? You can simplify it so that it becomes 5 over 7. That is okay. Because if it's a division that you're working with, you can split it, and there's a rule for that. We'll be talking about that in Algebra 1. So you can split it and you get 5 over 7. In this second problem here, it's the same thing as 36 over 100. How do we get that? Because we can move the decimal to the right twice, right? So that's 36 over 100, which becomes 36, square root of 36 over square root of 100, which becomes 6 over 10. This can be simplified or can just be written out as 0.6. So that's how we work with that problem, and that's the answer to the you try it section next to example 10. Now, there are times where we can estimate square roots. So let's talk about estimating square roots. So if we're going to estimate square roots, this occurs when you have somebody asking, for example, what is the square root of 83, they asked. Well, we know what the square root of 81 is. We know it's 9. And we know what the square root of 100 is. We know it's 10, right? If we're using square roots, right? So if we know that, then 83, right? We know 83 is very close to this, right? So we can give an approximation of the square root, right? Think of it this way. Between 83 and 100, between 81 and 100, 83 is closer to 81. So the answer should be closer to 9 than it is to 10, right? So this is where you're using approximation, right? That's why we use the squiggly line like that. So we're using approximation. And in this particular case, it's about 9.1, but it's an approximation. It's just, you can't give your answer as like 9.7 or 9.8. Those will be wrong because those are closer to 100. So just something for you to keep in mind. Your book goes on to give a few more examples with these approximations. When you give an approximation, feel free to multiply it by itself to see how close you are to that number in question. So you take 9.1, and if you were to multiply that by itself, so 9.1, let's type this in, 9.1 times 9.1, we get 82.81, and that's close to 83. So that's a good approximation. This takes some skill and some practice, but it's just good to be able to approximate. When you get problems like this, you're not going to be judged, intensely. Like, you don't have to give us the 5 decimal places with exactness. It's an approximation. So the important thing to keep in mind is that you just look at which one is it closer to. I try to split the difference here, and I say, which one is it closer to, that way or that way? And that's a key feature in approximating the square root. A calculator can give you a good value for the square root of a number, like this case, if you said square root of 83, sorry. And so your book also tells you an important observation. The calculator can only produce a finite number of decimal places. If the decimal representation of your number does not terminate within the limited number of places, then the number in your calculator window is only an approximation. So that's something interesting to keep in mind as well. Things like 1/8 will end if you were to, simplify this on a calculator. You get 0.125, right? But then you put things like 2/3, as I said, and it'll be repeating. So it's always good to have an idea of what they want you to do. The exact representation of 2/3 is 0.6 with a bar above it. The calculator will round it up. It'll be 0.6, several 6666667, but it's actually 0.6 with a bar above it if you're doing 2/3. So just an example of where these approximations are used and just how calculators work out the values. Let me know if you have any questions. Your book goes on to give you problems to find the square roots of different numbers. Write the ones that are undefined. The ones that are fractions and decimals, just do what we did, split them. You're allowed to split them if you're dividing. And then some other good problems are given to you in this section. You have about 82 problems. I would say number 1 to 81 odd is a good set of problems. But let me know if you have any questions, and I will see you in the video for 5.8.